Welcome to part 3 of the video series, and here we can see the output of um, the model which we ran in the previous video. It does make sense to a certain extent, but we can see that the output is very messy and in some parts does not make sense. For example, mold is extracted as a feature and so is extracted as an attribute. It doesn't make sense. Hotel, L, etc. Some parts doesn't make sense, but when we look at the output at a global level, this method looks good. So it extracts the nouns, adjectives, etc., and as the aspects, and to those aspects it uses the dependency parser to find certain things which describe that particular aspect. So if we look at the code, the highlighted one shows what are the POS tags or dependency parser tags used for the aspects, and below we can see JJ, which is an adjective, NN is noun, JJ is again plural adjective, RB is an adverb. So those words are collected as aspects, and below we can see with dependency tags n subject, n object, direct object, modifier, adjectival modifier, adverbial modifier, etc., being extracted as the attributes surrounding the aspects in the previous part. So I wanted to build a simple model with Spacy. So what I did was I went to this website online which uses Spacy's dependency parser to give a visual output of any statement we plug in. So to build a simple model, I used trial and error, using a few review statements from whatever reviews we've collected. So as an example for this demonstration, let's say the statement was the bed was dirty. So the bed is the noun, it is also a subject, and dirty is an adjective, which adjective obviously describes the noun. Right? So I used a few statements like this to build my own list of the implementation which we just saw, the latest model implementation which we just saw. So another example, I found the bed very dirty. The bed is again the n subject, it is a noun, dirty is an adjective, we have adverbial modifier which is very. So using these I came up with a list of what tags would mean aspects and what tags would mean attributes of that aspect, right? So this was the model which I came up with. Basically, we scrapped the data from using Selenium, and then we saved it to CSV file. Next, we pre-processed the data. So all the pre-processing we do are listed here. We remove emojis and symbols, alphanumeric words, special characters, duplicated codes, extra spaces, and then we remove periods in front of words. For example, people would have put a full stop and then started the sentence immediately without a space. So we remove the full stop in front of the words, and then we make the entire text lowercase. So these are all the pre-processing steps we did, and the next step is to tokenize the reviews into single statements. Why? Because Spacy is not a very complex NLP implementation, and also if the statements are single simple statements rather than compound statements, it will yield a better result. So that was the reason behind making all the review statements. If they had 5 lines, we tokenized the review text in a sentence tokenizer to take the individual statement, and then we used a count vectorizer to generate unigrams, bigrams, and trigrams. The idea was to use frequency to find insights here, which unigram, which bigram, which trigram occurred most number of times. The second processor output is to compute the sentiment of the statement. We used Laurie Williams' paper here, or code implementation here, Vader sentiment module in Python to compute the sentiment of the statements, and then we extracted the subject and object nouns using Spacy's NLP. The idea here is, or the assumption here is that when people write review statements, they talk about the noun or the subject or the object if it was a noun. For example, the bed is dirty, the bed is a noun, and the review talks about the bed. So in summary, if a statement is positive or negative, it means that the subject or object mentioned in that statement is written in a positive sense or in a negative sense. So that was an assumption of our model. So the third step, we extract the subject and object nouns using Spacy NLP. It's same as the previous step, the second part of the previous step, and then we extract words related to it using POS tags and dependency tags. Now in the second process, the output will be nouns and what sentiments they are related to. And the third part, we have nouns and what are all the attributes used to define them. So using these outputs, we'll be able to get some actionable insights. So moving on to how the dependencies were selected. As mentioned earlier, we used the online website in a trial and error method to take all those particular list of dependencies which I felt better fit or better described a noun in a statement. So we took ACL, AMOD, ACOMP, etc.